So we discussed the different forms of energy. Quickly, I will go through these forms. Energy, ability to do work, we call energy. Then different forms of energies. The energy which is stored in food, fuel, or energy which can be released by a chemical reaction. The energy which is released by a chemical reaction, that's called a chemical energy. So batteries, food, fuel, they all have chemical energies. Kinetic energy, when the object are moving objects have kinetic energy. If we raise the object to certain height, when object move or at present at a certain height, they have potential energy or gravitational potential energy. Energy which propagate or travel in the form of light, we call light energy. The heat energy, the change in internal energy is called the heat energy or thermal energy. Energy due to vibration of the particle, we call sound energy. Energy due to the movement of the charged particle, we call electrical energy. Energy due to or which is stored in the nucleus, we call that as a nuclear energy or the stored energy. Energy due to the movement of air particle, wind energy. And when object deform, changes its shape, size, length, they have elastic strain energy. These are the forms of energy which we discussed last class. Now the new topic is a conservation of energy. What is a conservation of energy? It states that energy cannot be created nor be destroyed. Actually, energy changes from one form to another. So example, if you drop an object from certain height, an object is present at certain height. Which form of energy this object will have? Then an object is placed at certain height. Which form of energy this object will have? The gravitational potential energy or potential energy?
Gravitational potential.
Yeah. So gravitational potential or potential energy. An example, this object is having 100 joules of gravitational potential energy. As it falls, the speed will increase. At the center or halfway, the potential energy, what happened to potential energy? Because the height is decreasing, so its potential energy will decrease. So example, if the potential energy is 50, and as the object is falling, its speed is increasing, so its kinetic energy is increasing, so its kinetic energy is 50. What it shows, originally, because the object was stationary or at rest, so it was not having any kinetic energy. All the energy is due to the height, that is the potential or gravitational potential energy. When the object is halfway or at the center, half of the potential energy changes to kinetic. So if originally potential energy was 100, now half of 100 changes into kinetic. So it will have 50 joules of kinetic and 50 joules of potential. Potential energy is the energy which is due to change in the height. When object is at certain height, the energy which the object have, that's called gravitational potential energy or potential energy. When the object just before hitting the ground or when it's about to hit the ground, because it's on the ground or just about to hit the ground, so there's no height. So what will be the potential energy? The potential energy is 0. And what is the kinetic energy? The kinetic energy will be 100. So what it state, you can see here. So originally it was having a potential energy or gravitational potential energy. So as it falls, its potential energy changes into kinetic energy. So this is known as a conservation of energy, that energy actually transform or change from one form to another. If one form is decreasing, the other form of energy will increase. Is it clear, the concept of conservation of energy or change of energy?
Yes.
So if an object at certain height the potential energy of object is 100 joules, and out of 100, 20 joules of energy is lost to the atmosphere or surrounding in the form of heat. So 20 joules of energy is lost in the form of heat. The question is, what is the kinetic energy? What will be the kinetic energy at the base? At position A, it was having only a potential energy. As it fall, it lost 20 joules of energy in the form of heat. How much is the kinetic energy at the bottom? What will be the kinetic energy? So originally the potential is 100, 20 is lost. So how much is the kinetic energy? Kinetic energy is equals to 80 joules. But the overall energy change is same. The total energy does not change. If the total or original energy is 100 joule, the final energy is also 100 joule. So this is a conservation of energy. It states that total energy of an object does not change. It remains same. It only changes from one form to another. So energy cannot be created. Actually, we are not creating energy. We are not destroying energy. We are only changing one form of energy to another. So everyday examples of conversion of energy from one form to another. Example, a stone is thrown upward. If you're throwing a stone upward. So which form of energy you're having? Because we are eating food to get energy. So we have a chemical energy, a human body. When you throw the stone and you are throwing the stone upward, so stone start to move. So which form of energy it will have? Kinetic. When it reach the maximum height, at the maximum height, it will have potential energy. Then it is returning to the ground. So potential energy is changing back to kinetic energy. And at it hits the ground, what it produces sound also, and it produces heat. So you can see there are changes in energy. The total energy will be same. So what energy which we supplied, the same amount of energy is there, all the points. So if we supply 100 joules of chemical at the last example, if 30 joules of heat energy is there, then 70 joules of sound energy, the total energy will be 100. Is it clear, this example? So first, there's a chemical energy, because a food or a fuel, as we are eating a food using a chemical reaction, we remove the energy or take out energy from the food. That's why food is having a chemical energy. Then as we throw it up, as the object start to move, it will have kinetic. Then the object reach a certain height, it will have potential or gravitational potential energy. Then object is returning back, so its speed is increasing, kinetic. As it hits the ground, it will have heat energy and sound energy. Another example for a waterfall. So what is the change in energy here? Because the water is at certain height. So when object at certain height, they have potential energy, or we can say gravitational potential energy. Just before hitting, the base, it will have kinetic. If there is no loss of energy, if it is having 5 joules of gravitational potential energy, just before hitting, it will have 5 joules of kinetic energy. So energy here, the gravitational potential energy actually changed to kinetic energy. Then calculations related to energy. If you want to calculate the kinetic energy, as we know, if object is moving faster, it will have higher kinetic energy, or object is having a greater mass, it will have greater kinetic energy. The formula is half mv square. Kinetic energy is half mass multiplied by velocity or speed square. We'll get the kinetic energy. So word example, a car of mass 2000 kilogram, it is traveling at a speed of 10 meter per second. Calculate its kinetic energy. What is the kinetic energy of the car? Calculate the kinetic energy of the car. So half mv square, 0.5 multiplied by mass multiplied by velocity square. That's equal to 100,000, because it's half mv square or 100 kilojoule. Because in the formula, it's half mv square. Maybe you did not square. You have to square this speed. So half, or 0.5 multiplied by mass, which was 2000, multiplied by speed, it's 10, but the formula half mv square. So this should be square. Is it clear, this example?
Yeah, it's clear.
Then the gravitational potential energy or potential energy, if you potential energy stored due to change in the height. If an object is raised to greater height, it will have higher potential energy. The formula which we use to calculate the potential energy or gravitational potential energy is mass multiplied by gravity multiplied by height, or you can say mgh. So a word example related to gravitational potential energy. What's the answer for this? A stone of mass 5 kilogram is lifted above the ground at 2 meter height. What is the gravitational potential energy? The value of the gravity, it's 10. What's the answer for gravitational potential energy? So 5 multiplied by 2, 10. 10 multiplied by 10 is 100. So mgh is equals to 100. Then the energy resource can be a renewable energy resource, or energy resource or source can be non-renewable. Renewable means, look, two things happen for energy sources. One is the rate of formation, the speed of a formation. And the other one is rate of consumption, like how we are using it. So if rate of formation is higher, like it is forming at a greater rate, but we are using, or our consumption is too small compared to how much it is formed, then that energy resource is called a renewable energy resource. Example, energy from the sun, the solar energy. So solar energy or energy from the sun, we call that a renewable energy resource. What is the reason for that? Because the sun is giving enormous amount of energy to us, or it is forming at a consumption means utilization, using. The term consume means use. So speed at the rate of formation, like every day, example, a sun is giving 100, example, 1000 megajoules. This is just an example, it's not an accurate value. So every day, the sun is producing 1000 megajoules of energy. But we are only consuming, as this energy, we are receiving it out of this 1000 megajoules. Example, we are only consuming or we are only using 2 megajoules. This is what we use. So 1000 is produced, but we use a small quantity out of it. That's why this kind of energy resource is called a renewable energy resource. It produced more, formation or production, and utilization or use is less. That's why we call the energy from the sun or solar energies are renewable. But non-renewable means the rate of formation is small or slower rate of formation as compared to rate of consumption. So amount of energy which is formed every day is a small proportion as compared. Every day coal is not forming, it take about 200 million years to form or convert into coal. So rate of formation is too small and rate of consumption is too high. That kind of energy resource is known as non-renewable energy resource. So example, solar was example of renewable. Non-renewable example, coal, oil or gas. These are non-renewable energy resource. So the formation, rate of formation means the speed of formation. Like every day, sun is generating too much energy because it has too much fuel available. So formation or production is more, but what we utilize is less. Same way, if formation is less as compared to utilization, that kind of energy resource is known as non-renewable energy resource. So renewable energy sources that can be replenished over a short period of a time or reproduce over a short period. Replenish here refers to reproduce. So if we can reproduce the energy resource or energy resource produced in a short time back again, we call that as renewable energy resource. Example, solar energy. Example, solar energy, wind energy, hydroelectric energy, and geothermal energies. What is the solar energy? Solar energy means energy from the sun. It's a renewable energy resource. So sun is giving enormous amount of energy, and every time this energy is available. Like it's not like, for example, in January you will have more energy, but as you reach as December, the amount of energy released by the sun or given out by the sun changes. No, it does not happen. Every day, same amount of energy is available. So that kind of resource is known as renewable energy resource. So solar energy is renewable. Wind energy, what is the wind energy? Because what happened, as we discussed in the last class, that the sun provide heat energy to both land. So the land and the sea both absorb energy from the sun, but because the proportion of the land is small as compared to proportion of the water, that's why the air above the land will become hot. As the air above the land will become hot, this hot air molecules will rise. So as these hot air molecules will rise, the molecules which are above the sea, they start to move towards the land, and this is responsible for wind energy. So it's the solar energy. If solar energy is non-renewable, renewable means every time it is available or excess is there, too much energy is available. So wind energy is also due to sun, so that is also a renewable energy resource. What is hydroelectric energy? The hydroelectric energy is from the term hydro. Hydro means water. So what happened? It's related to the water cycle. The water molecules which are there evaporate due to the heat energy. So these water molecules will rise and it will form clouds. So the water molecules will form clouds, and from these clouds, when it will rain at higher altitude, so as it rain at higher altitude or mountains, so now the water is at higher altitude or at certain height. So which form of energy this water will have as it is at higher altitude? So when water rises to a higher altitude, which form of energy it will have? It will have hydroelectric or hydroelectric energy, because we can use this energy. I will discuss this hydroelectric in detail. That's why I'm just giving introduction here. So what happened due to the evaporation of the water, it formed water vapors and then it formed clouds. And from these clouds, when it rains, the water rises to certain height, because normally it rains at higher altitude frequently. So water will store at higher altitude, and which form of energy this will water will have? It will have gravitational potential energy. So hydroelectric is also a renewable. Why? Because this is due to the sun as well. What is geothermal? Its energy, geo means earth and thermal means heat. So our earth, because there are three layers, crust, mantle and core. So the thinnest layer is the top layer, but the center of the earth is dense, and that we call that as a core. So energy which we obtain or which we take out from the core, or energy released by the core of this earth, that energy is called geothermal energy. Geothermal energy, too much energy is available and we are not utilizing that energy. How we can utilize these energy, that's the next topic. The first one is introduction. You should have a concept that whether energy resource is renewable or non-renewable. Energy source is renewable if it can replenish over a short period of a time, or it can be produced or reproduced in a short time. So solar energy, wind energy, hydroelectric energy, geothermal energy, these are some examples of renewable energy resources. Non-renewable energy sources. So non-renewable are the energy sources that cannot be replenished over a short time. Example, coal, fossil fuels, nuclear fuels. Like example, if you are buying, say 1 kilogram coal, and you use it, you burn to produce heat energy, can you use the same coal again to produce the energy? Example, we have 1 kilogram of coal. We burn to produce heat energy. Can we use, after burning it completely, can we use this to produce energy again? It cannot be used again. So if it cannot be used again, energy cannot be replenished or reproduced over a short time. That's why we call that as a non-renewable energy resource. And the rate at which we are using is much higher as compared to rate at which it is formed. Like coal, it takes about 200 million years to form a coal, but we just take maybe maximum 1 hour or 2 hours to burn this coal completely. So it's taking 200 million years to form, and we are just taking 2 hours or 3 hours to burn it completely. So means we are consuming at a short time, and it take lot of time to produce back again. That's why we will reach a certain point where on earth we don't find this coal, and we call that as a non-renewable energy resource. Is it clear? The difference between renewable and non-renewable energy resources? Any doubt in this? Then how we can generate electricity using our renewable energy resources or energy sources? We can use a solar energy. So how a solar energy can be used to produce electricity? So first, a sun, because without a sun, you cannot generate this electricity. So sun is providing both heat and light. So energy in the form of heat and light will receive on earth. How we can convert this solar energy to electrical energy? For this purpose, we use a device or cells known as solar cells. These are solar cells, but when lot of cells are together, group of solar cells are together, we call that as solar panel. Like one is called a cell, but if lot of cells are together, so collectively what we call that as a solar panel. And what is the characteristic of this solar panel, or which is a group of different solar cells? So when the light or heat energy from a sun is absorbed by these solar cells or solar panels, what they produce a moving charges or electrons. How solar cells are made up of? Solar cells are made up of element called silicon. I can explain internal working also, but that is extra thing other than the topic. So if I have a time after the class, I will explain. But I'm first focusing on the main topic, which is they will not ask what is the internal working of a solar cell. But normally solar cell consists of element silicon. So when the light falls on this solar cell or solar panel, which is a combination of many cells, so what they produce electrons. Their atoms will lose electrons, and these electrons start to flow. So whenever electrons is a charged particle, when electron flow, which form of energy they will have when the charges flow? Which form of energy is there when the charges are flowing? Electrical energy. because whenever the movement of the charge is there, so that's having an electrical energy. The solar cells or solar panels does not have any moving part. There is no part moving here. Just the light falls and instantly it will generate a small amount of current which can be used or stored in the battery. But solar cells, you need too many solar cells to produce enough energy to light up or to supply energy to one unit of house. So we need lot of solar cells to produce energy which can be consumed by the house. So in solar cell, the solar energy is the energy from a sun, and how a sun is producing energy, as we discussed, a sun produces energy by a nuclear fusion. So on the surface of the sun, there is a nuclear fusion. What is nuclear fusion? When the lighter atoms such as hydrogen or isotopes of hydrogen, they collide with each other. This result in a formation of a heavy nucleus such as helium, and it release energy. That energy which is released in the form of light and heat. And this energy which we obtain from the sun is originally is due to the nuclear reaction on the surface of the sun. So what happened? The solar panels absorb energy from the sun. Yes, you can take the screenshot. I already shared this presentation on the group. So if any one of you miss any topic, you can also go through this presentation. So normally solar panels, solar panels absorb energy from the sun and they convert this energy directly to electrical energy. So most of the solar energy is collected through a photovoltaic cell, or which we also call a photo cell. The sun ray contain heat and radiation which falls on the this photocell or a solar cell. So you can see here above the or the top of the building, or my sound is clear or it's lagging? Okay. If you feel or my sound, if any lagging, then just you can let me know. Okay, so what happened? The sun is providing heat energy that falls on the solar panel. So when it falls on the solar panel, it produces electrons, and these electrons move in the wire. So when these electrons move through the wire, it will give out when it passes through a lamp, it will give light energy. So what is the energy change here? These are the actual pictures of a solar panel. This one is a solar panel. It consists of many cells. Electrons are there in silicon. They are released when the light falls on the solar cell. So what happened? The light from a sun as a light from the sun fall on this solar panel, the electron, the silicon is an element. So element loses its electron, so the electron will start to move and flow in the circuit. Is it clear, the working of a solar cell? Any doubt in this? So if we draw energy conversion diagram, energy convergence in a solar panel or a solar cell. So first, which form of energy is there? The heat energy or the light energy from the sun. It's heat and light, both should be there. The heat and the light energy from the sun, when it is strike the solar panel, this will convert into electrical energy. This is the energy conversion. But what is a block diagram? Like, what are the things which we are using? The block diagram, first we have a solar panel. Is it okay now? Is it clear, the sound?
Yeah, it's clear.
Yes, sir.
Okay. Today, internet connection, I think, is not stable. That's why it's lagging compared to normal classes. So what is a block diagram? Block diagram, what we have a solar panel and we have transformer. What is the purpose of the transformer? When we want to supply energy from one place to another, we use transformers. The working of a transformer, you will learn in block 4. Electricity and magnetism, you learn the complete working of a transformer. So just keep in mind, what are transformers? Transformers are used for transferring energy, electrical energy, mainly from one place to another. Now, what are the advantages of solar cells? Number one, low running cost, because you don't have to buy anything, you don't have to add any fuel to this solar cell, so you don't have to spend too much to run or to work the solar cell. No major pollution is there, it does not produce harmful gases because it is not burning anything, and it is a renewable energy resource. It means you can use again and again. But what are disadvantages? It's low efficiency. It's not too much efficient. You need a lot of area to cover or build this system for a solar cell. Its availability vary. Like example, in a daytime you can have solar energy, but at night you cannot have a solar energy. So it's not a reliable. Even in one day, if you have a cloudy weather and next day you have a sunny weather, it means both days you will have a different output from the solar panel. So its availability varies. And the amount of current which is produced, yeah, it is costly also, that's correct. An amount of current produced is very small. We need devices which need a greater amount of electricity, and it is initial cost is high, running cost is low.